We're being asked to prove that if n squared minus 4n plus 5 is even, then n must be odd. The first thing to note here is this is quite difficult to prove directly, because saying this is even and working backwards to n is very tricky. And this is where the contrapositive is really powerful. Now remember that the contrapositive says that if A implies B, then that is exactly the same as saying not B implies not A. So the first thing we're going to do is write the contrapositive. Now in this case B was n is odd, so not B is n is even. And A was n squared minus 4n plus 5 is even, so not A is n squared minus 4n plus 5 is odd. So now we have our contrapositive, we're going to try and prove this statement. This is much easier to prove because now we're talking about the simpler thing, proving the more difficult thing. If n is even, then n is equal to 2k for some k. So we can write that whole expression by putting 2k in for n. And when we do that, we can factorize out 2 from the beginning and get something of the form 2a plus 1, which means that this whole thing must be odd, which means this is odd. So what we have shown is if n is even, then n squared minus 4n plus 5 must be odd. But that means the contrapositive is also true. And the contrapositive is n squared minus 4n plus 5 is even, then n is odd. So this is how we can use the contrapositive to prove things where it's difficult to go one way, but much easier to go the other.